Hi everybody, welcome to our first topic in the Year 11 Extension Mathematics course. We are starting with polynomials. Usually we do this as our third topic, but this time it is going to be our first topic. In this unit we'll study a class of functions or a group of functions called polynomials. You're fairly familiar with these from your Year 10 work because you've looked at quadratics, you've looked at cubics, and in the early years, you've looked at linear equations. These are all polynomials, okay? But what we're going to be looking at is polynomials of higher degree. So we've looked at quadratics, we've looked at cubics. We're going to look at polynomials of the power of 4, the power of 5, the power of 6, or any power, and we're going to call that power n. We're going to learn to find the zeros like we did with our quadratics and cubics. We're going to introduce a new word, and the new word we're going to have a look at is roots. Okay, a zero and a root are not exactly the same. We're going to have a look at those of polynomials and examine the properties of the sums and the products of the roots of our polynomials. There's a lot of words that we have not come across before that are going to come into this topic. So the terminology here, you're going to need to become fairly familiar with, and that language is a language I'm going to be using through the topic. I will explain it as we go, but you need to become familiar with that. And if you have a look through those words, you should be already familiar with most of them. Even some of these ones over here from junior school and primary school, but we're going to use them in a more complex way than what you've used before. So for this topic, it's chapter 10 in the Cambridge textbook of the Year 11 Extension 1 book, and there are sections from 10A to 10H. Because we've changed our lessons to 75-minute periods, some of the exercises might be combined. I'm still working on that. We're going to start with the language of polynomials, and I'll probably group that together with graphs of polynomials and functions because we're fairly familiar with that. So we're going to start today with the language of polynomials. Okay, so you'll need to fill in the booklet as you go through. I would be taking notes and writing those down while I write them down, and you might need to annotate and add some extra notes in there. So 10A, the language of polynomials. Okay, so we're used to seeing a polynomial or a cubic written as y equals, or in our course last year we looked at f of x equals. We're just going to write them as p of x equals, being p for polynomial, and they're going to take along this form here. And all that means is there's a number out the front of a term with a particular power. So we've looked at equations before that have looked like y equals, for example, 2x squared plus 4x plus 3, where this 2 would be our a to the n, our x to the n would be our x squared. This would be our highest power here, and we're going down in powers, and our last term there would have an x to the 0. So we have actually looked at that before. So when we have with our polynomials, what we want to do is put our power that has the biggest number out the front, and that power with the biggest number is the leading coefficient of our polynomial. So we always want to make sure that we're writing it with our largest power of n out the front. So when we're writing a quadratic, we're always writing in the terms of x squared. We wouldn't put x out the front plus x squared. We'd always have that term with the 2 out the front at the start. The same as with the cubic. We'd always write a cubic as, for example, x cubed. We'd have our squared term next. I'm just making one up here. We'd have our single term next, and then our last term. Obviously, some of these terms might be missing. We might not always have a squared and an x in there, but we'd have our highest power to start with, and that's the way I need you to write your polynomials. So this is just a general form of writing a polynomial. It's starting with our power of n. That's the biggest. That's our n. And our next one is 1 less than that n, another 1 less than that n, or 2 less than our original, and it keeps going down until we have our last term here, which is going to have an actually x to the power of 0 in it, which we know is 1. So we generally don't always put that x to the power of 0 in there, but it can be put in there. Now, our polynomial has also often values out the front. Okay, so our a to the n, our a to the n minus 1, our a to the n minus 2 are numbers, like we have up here. A 2 would represent our a to the n. in front of our x cubed, we've got a 1. That would represent our a to the n. So that's just saying to me, that's our coefficient of the powered term. So a to the n is our coefficient of x to the n. So over here, 2 is the coefficient of x squared. So we've looked now at a couple of new words. So I'm going to go back up to the terminology as we introduce you here. The term coefficient, we need to know here, constant term, leading term, leading coefficient, and degree. I need to talk about all of those now. The degree is going to be the highest power that we have in our polynomial. And we'll show you that as we go down a little bit. A coefficient is the number in front of the term, or in terms of the x, so we will say in front of x, number in front of the x, or the x squared, or we might say x to the n. Our constant term, we'll say, has no x in it, so it's just a number, there's no variable, so it's constant. Our leading term is the term with the highest power of x. So I want you to write these in there so that you know these. And our leading coefficient is the number in front of the highest power. So let's go back and have a look at that and look at some questions as we go through. So if you were in my accelerated class before, you may be familiar with some of these terms from last year. Okay, so let's have a look here. Okay, so we'll look at those terms as we go through here. So here's our polynomial, a general form, and we're saying that if a to the n is equal to 1, so if that value there, a to the n is equal to 1, our polynomial p to the x is monic. And that would be something like this second cubic here. The number out the front of the x cubed is a 1 and it was a monic. So if you think back to when we were factorizing our quadratics, we looked at monics and non-monics. It's the same as what we looked at then, okay? When there was a number out the front, there was a non-monic. When there's a value of 2 or more out the front of that, it is a, delete what I've just said. When there's a number 1 or no other number out the front, it's a monic. When it's got another number other than a 1, we call it a non-monic. Monics just means 1. Okay, have a look at the second line here. When p to the x is equal to a with a little 0, so that's our last term there. Okay, and when that doesn't equal 0, that last term, our polynomial is of 0 degree. So if we think about what the terms up above said to us, this polynomial here has degree 2. This polynomial here has degree 3. So what it's saying over here is, if our polynomial is of 0 degree, then we don't have any value on our polynomial of an x other than this one here, x to the 0, which is just going to give us a constant term. That is, it's a constant polynomial. So it might take a little while to get familiar with these. Okay, so we've looked at monic. When the number out the front is a 1, it's a monic. The degree tells us the highest power of our polynomial. And if a polynomial is equal to 0, so if all of this here is equal to 0, we call it a null polynomial. So there's a few words to get the hang of there. Okay. It says, remember, terms without an equals are expressions, and with an equals are an equation, and need to be treated separately. So we need to think about that, and that's always been the case since your early junior school, but we'll look at that as we go through. So here's a good example. For the polynomial p of x is equal to, we've got 3x to the 7 minus 2x to the 4th plus 12x cubed plus 5x squared minus 3x plus 1. We want to find out all of these things here. Now, first note with our polynomial, okay, so that's what p of x is is called our polynomial. It's already written in the form from the highest power down. So that's what I want. If it's not in that form, you need to write it in that form. Part A says find the degree. The degree is 7. So if you think what I wrote back before on our terminology, the degree is the highest power. Of p of x. Is the polynomial monic? No. Why is it not monic? Monic means 1. Monic means 1. Our polynomial has 3 out the front of the highest power. So I will get rid of the word our, because I don't need to have that in there. P of x has 3 at the front of our x squared. That 3 is a coefficient. So what we say the number out the front of the x squared is a coefficient. State the leading term. And that should stay state there. Sorry, fix that up. The leading term. The leading term is the term that has the highest power. So that's our leading term. We've popped it in order from the highest power down to the lowest. So that one is our leading term. Let's write that one in there. 3x squared. Its coefficient is 3. Its degree is 7. But the leading term is all of that. What is the constant term? Well, the constant term is the term that does not have any x in it, and it is 1. That's 1, and we'll say no x present. Okay, so we've gone through a few of those things. They're terms you're going to have to come and get quite good at. And there's one more to go. What is the coefficient of x to the power of 4? Coefficient is the number out the front. So the coefficient of x to the power of 4 is -2. So we've looked at the terms degree. Degree is the highest power. It's monic if the term that has the highest power has a 1 out the front. So if that 3 was a 1, this would be a monic polynomial. Ours is not. The leading term is all of that term that has the highest power. So 3x to the 7 is our leading term. The constant term is this 1 at the end. It has no x in it. It's constant. It doesn't have that variable x in there. And the coefficient of x to the 4 is -2. It's the number out the front of x to the power of 4. Likewise, the coefficient of x cubed is 12. The coefficient of x to the 7 is 3. That's language you need to get good at, and you will practice that in the first exercise. But let's keep going. Adding and subtracting polynomials. 2 polynomials can be added or subtracted by collecting like terms. We're pretty good at this already. I want you to pause the video and have a go. See if you can come up with the answers there. But we've got 2 polynomials here. P of x is this one here. Q of x is this one here. The notation is no different from our f of x before that we've used. It just gives us a function name. So this function is p, this one is q. We're going to add these 2 functions together. So we're going to add all of this plus all of this. So I'm going to write it down. So if you would like to pause the video, I've just written all those terms down there, and now we're just going to collect like terms. We have 1x to the 4th. Let's look at x to the cube next, or x to the power of 3. So I've only got one of those, plus 2x to the power of 3. X squared, I've got -5 plus 3, so I've got -2x squared, plus 3x minus x is going to be plus 2x, so I'll cross those out as well. And I've got -6 plus 1 will give me -5. That is my answer for p to the x plus q of x. Likewise, let's go q of x minus p of x. I'll pause that and we'll work that one out. Okay, so see if you've got the same as me. What I've done is taken my q to the x, which is here, take away p of x. When I'm taking away p of x, I'm taking away all of p of x. So that will be the mistake that people will make. So what I will have is 2x to the cube plus 3x squared minus x plus 1 minus x to the fourth, because the minus goes through to each term, plus 5x squared minus 3x plus 6. And now we can group together our like terms. X to the fourth, I'm going to go minus x fourth first. Let's see if my pen is on it. It's all right. We've just got a very thick pen here. X to the power of 3. I've got the 2x to the power of 3. It's still there. I've got 3x squared plus 5x squared, which is 8x squared. I have minus x minus 3x, which is a minus 4x, and 1 plus 6, which is 7. Make sure you've got that. And the thing that people are going to make mistakes on in there is just that minus, and that's just a silly error. You need to think when you're doing things, basically. Other than that, you should be fine with those questions, and you'll get some practice in the exercise. Let's have a look at the next part. Okay, multiplying polynomials. Two polynomials can be multiplied by multiplying every term in the first by every term in the second. Now, we've done these before when we've done things like x plus 2 times x plus 3, and you are foiling that. You're going to do the same with this. It just is going to be a little bit messy. Let's write out p to the x times q of x, and then we'll see what we end up with. Okay. Now, you guys are used to foiling this. I am going to foil it, but just think of it basically as if I'm timesing every term in the first by every term in the second, I'm going to times x to the power of 4 by each of these terms. Then I'm going to times minus 5x squared by each of these terms, 3x by each of these, and then minus 6 by each of those. And that's the easiest way to do it. So let's go and use this term here first. X to the fourth times 2x cubed is going to be 2x to the 7. Remember, when we're multiplying powers or terms with powers, we add them as the index getting added to give us 7. X to the fourth times 3x squared. And likewise, let's keep going on. That's my first term multiplied by each of those. Now I'm going to multiply minus 5x squared by each of these. We get minus 10x to the 5, minus 15x to the 4th, plus 5x cubed minus 5x squared. Now 3x times each of this second bracket. X cubed plus 9x. Oops, sorry, I've made a little mistake there. I'm going to do that again. 3x times each of these is going to give me 6x to the 4th is my mistake that I just fixed up there. Plus 9x cubed minus 3x squared plus 3x. Lucky last, minus 6 times all of those. I'm going to have to flow over to the next line there again, I think. If I don't have enough space. No, we might make it. Minus 12x cubed minus 18x squared plus 6x minus 6. Okay, now you need to collect like terms. So that's going to take a little bit of time. I'm going to pause the video and do those. I'm going to start with powers of 7 and work down. You work yours out and we'll see if we get the same answer. Okie dokie, that's what I've got when I've multiplied those two polynomials together. That's a fairly full-on one, okay, because you're having to do a heck of a lot of work and there's actually a lot of room for error in that one. So see if you've got the same as me. If you didn't, perhaps I'm wrong. I may have made a mistake. I think I've got it right though. Let's have a look at the next part. Identically equal polynomials. Two polynomials are identically equal if the corresponding coefficients of the two polynomials are equal. So we'd say p of x is identically equal to q of x. And this is an excellent question. We are going to ask you these. The HSC questions are very similar to these, and you've seen these before with cubics or squares. The example says if I've got 3 of x times x minus 3 times 2x minus 2x squared minus 1 is equal to this polynomial, find the values of a, b, c, d, and e. they're identically equal. We just need to expand that first polynomial out so we get something that looks like this, and then we can just equate polynomial. So I'm going to have a look at the left-hand side there, and we're going to fix that up and equate our coefficients. So probably the easiest way to do this would be to times our first two brackets together. So I'm going to FOIL those first two, so I get 3x squared minus 9x, and I want to multiply that by my second bracket and FOIL the second one. So 3x times both of those, 9x minus 9x times both of those. I might just write that out. I know a lot of you in my class do like to do it this way to make sure that we don't make any mistakes. So I basically split that first bracket up. I FOILed it. I've just popped the... Sorry, my video is playing up there. So I've just split the brackets up. I'm just foiling it. I'm just popping an extra step in there to make it easier for us. So let's expand those two brackets. So I'm going to get 6x to the 4th minus 3x squared minus 18x cubed plus 9x. I'm just going to write those in order of descending coefficients. So I'm going to have 6x to the 4th minus 18x cubed minus 3x squared plus 9x. What you will note is we have similar format to what we've got up the top. 4, 3, 2, 1, nothing. 4, 3, 2, 1. I need to have an x to the 0 on the end there, like that. I can now equate coefficients, okay? Therefore, a is going to be 6, because the number at the front of x to the 4th is 6, and that is my a. B is the number at the front of x cubed, and that is minus 18. C is the number at the front of x squared, which is minus 3. D is at the front of x, which is 9. And E is the constant term. I didn't have one, which is basically saying that that is going to be 0. And that is my solution. So that's a really handy way. Often they're not that easy, and you have to do a little bit of working out. But that gives us the first part of chapter 10. 10a, I want you to have a go. Have a look at the questions you need to do, and please have a go at the harder ones, okay? Remember, we're extension 1 now. You guys are really amazing, and you come back to me with any questions, and we'll push on from there.